All right, so like I said, we're just going to discuss types of numbers and rational numbers in details. Yeah, so here we'll only do rational numbers, and then the next session we'll do irrational. Okay, so on the types of numbers, I'm just going to go back a bit from what you already know. I'm going to go back to what you already know rather. So we'll discuss what even numbers are, what odd numbers are, what integers are. We'll discuss different types of types of numbers. Okay, so what are even numbers? So even numbers are simply just, the simplest definition is simply the numbers that end with 0, 2, 4, 6, and 8. So any number that you know which ends with 0, 2, 4, 6, 8, it's known as an even number. So when we say 20, 20 is an even, 10 is an even, 100, as long as it's ending with what? Any of these numbers here. When you say 22, as long as there's a 2 there. When you say 54, as long as there's a 4, it's ending with 4. When we say 98, as long as it's ending with any of these numbers here, it's called an even number. Odd numbers. So odd numbers is any integer that cannot be divided exactly by 2. Or the other definition of odd numbers is any number that ends with these numbers you are seeing here. So we also have negative and positive odd numbers. All right, so an odd number is simply just any number that ends with any of these numbers that you are seeing here. And the other definition is that any number that cannot be divided by what? By 2. Or if you divide it by 2, it's going to leave a remainder 1. That is an odd number. We also have another set of numbers which are called complex numbers. So complex numbers are simply just complex numbers are simply just numbers that are in the format, a plus I, b. Sometimes they use x plus I, y. So what this means is that the number here that does not have I is called the real part of a complex number. So this one is called the real part of the complex number. And then this one which contains I is the one that we call the imaginary part of a complex number. So sometimes complex numbers are known as imaginary numbers. So let's look at another set of number which are real numbers. Oh, sorry, let's start with prime numbers first. So prime numbers are simply just numbers that only have 2 factors. So these numbers only have 2 factors, which are 1 and itself. Meaning, when you look at, for instance, 2 is the smallest prime number that we have. So 2 contains only 2 factors, which is 1 and 2. There's no other number except fractions that you can multiply to get 2. Yeah, so 2 is the smallest prime number, then followed by 3. Followed by 3. Then you also have 5. Yeah, so some of the examples are here. 9 is not an odd number. Rather, it's not a prime number. 9 is not a prime number. Why do we say that? Because 9, we can have 1 times what? 1 times 9. So meaning we have 2 factors, 1 and 9. Apart from that, we can also write it as 3 times 3. So we have 3 factors for 9. We have 1, 3, and 9. These are the factors of 9. Meaning 9 is not a prime number. So prime numbers only contains 2 factors, 1 and itself. What are natural numbers? So natural numbers are simply just counting numbers starting from 1. So whenever you're counting, and then when beginning to count, you start from 1, you start going up. You start from 1, you go to 2, 3, 4, 5, 6, 7, 8, going up. It means that you're counting using what? You're counting using natural numbers. Okay. What are whole numbers? So whole numbers are simply just these are simply just a set of natural numbers plus 0. So when you get a set of natural numbers and then you add a 0, in other words, if you start counting from 0 going up, that implies you are using whole numbers to count. But if you start from 1 counting, it means that you are using natural numbers. What are integers? So integers are simply negative and positive whole numbers. So when you get positive and negative whole numbers, you put them together, you come up with a set known as the set of integers. What are rational numbers? So rational numbers are simply numbers that can be expressed in the form A over B, where A and B are members of what? They are members of integers. So this Z represents integers, and then B should not be equal to 0. What happens if B is 0? If B is 0, this whole expression will become undefined, because any number divided by 0, the answer is what? Undefined. So B should never be equal to 0 for this fraction to qualify that it's for this fraction to qualify that it's a rational number. And A and B should be members of the set of what? Integers. So A and B should both be what? Integers. For this fraction, which is in the format A over B, to qualify to be what? To qualify to be a rational number. All right, so that is how you define a rational number. And the other thing is that A and B should be in its lowest term. Okay, so we have also another set which is called the set of real numbers. So on rational numbers, I only explained rational numbers. So the opposite of rational numbers are called irrational numbers. You just put another R there, and it becomes irrational numbers. So we said rational numbers can be expressed in the form A over B, meaning irrational numbers can't be expressed in this form. What are these numbers? Do we know these numbers? Yes, we know the numbers. What are they? So one of the numbers that is known as an irrational number is the square root of 2. So the square root of 2 is an irrational number. Why is it an irrational number? It means it's an irrational number because it's impossible, it's practically impossible for you to express this solution, the solution of the square root of 2 in the form A over B. So sometimes you can't just guess that root 2 or root 5 is an irrational number, or root 6 is an irrational number. We can't just guess. So how do we know? How do we prove that the root of 5 is an irrational number? How do we prove that the root of 2 is an irrational? How do we prove that the root of 6 is an irrational? How do we prove that the root of 2 plus 1 is an irrational number? How do you prove that the root of 3 plus the root of 2 is an irrational number? So we are going to discuss that in the next session that we are going to have. So these are some of the questions that a lot of people find challenges with. Yeah, so a lot of people find challenges when they are faced with a question which says, prove that. A question just comes as, prove that the root of 2 is irrational. So if they ask you this question, this is one of the questions that confuses a lot of students in universities. So how can you prove that the root of 2 is an irrational number? So we use a formula or a method called the contradiction method. So we use the contradiction method to prove that the root of 2 is an irrational number. So all these things we're going to learn. So what you just need to do is to not, rather, you shouldn't just be missing the classes. That's all. You shouldn't just be missing the classes. And in case you want to find more about the classes, you can inbox me. Then I'll explain more about how I conduct these lessons. It's not only for Mlungushi, Apex, or what I conduct for a lot of universities. All right, so we have talked about rational numbers and irrational numbers. So rational numbers, we said they can be expressed in the form A over B. What this means is that they can be expressed in a fraction form. And then irrational numbers, they can't be expressed in the fraction form. Now, how can you prove that this number is a rational number or this number is an irrational number? That is what we are going to discuss in the next session that we're going to have. So let's look at another set of numbers known as the real numbers. So what are real numbers? So real numbers are simply just a set that is formed when you combine the rational numbers, when you combine rational numbers and irrational numbers. When you combine rational numbers and irrational numbers, you come up with a set known as the set of what? Real numbers. So when you combine rational numbers and irrational numbers, you come up with a set known as what? Real numbers. So in other words, when you combine all the numbers that can be expressed in the form A over B and all the numbers that can be expressed in the form A over B, all the decimal numbers and all those other numbers that can be expressed in this form, then you have a set known as the set of real numbers. When you add these two sets, the set that you're going to get is the set of what? Real numbers. Okay. So these are some of the examples that we have. So on the set of real numbers, we have numbers that terminate, and we also have numbers that do not terminate. I'm going to explain that. So 1 over 2 can be expressed in decimal form, and this is going to be what? 0.5. So 1 over 2 gives us 0.5 in decimal form. So this is a rational number because you are able to express this 0.5 into what? A fraction form. And then we have another number, which is pi. It is practically impossible to express pi in a fraction form. So pi is a number that keeps on going this side. And it's impossible for you to express pi in the form A over B or in a fraction form. And hence pi is what? Is an irrational number. So 10 is also a rational number because you can express 10 in a fraction form and it can be written as 10 over 1. Okay, proceed. Yeah, so some real numbers have decimal parts which repeat. So we have some real numbers that have repeating decimal parts. So you can see that here 1, 2 is repeating 1, 2, 1, 2. We have 1, 2 continuously repeating, which can also be written like that. So when you have a number which is, for instance, let me use an example. This same example has been given. 1, 2, 1, 2, 1, 2. So instead of writing all these 1, 2, 1, 2, 1, 2 going like that, you just have to show it in this way. You just say 2.2, 2.12, and then you put a bar on top there, which tells us to say 1 and 2 are continuously repeating as you go to the right. Okay, so let us take a look at rational numbers in details. So rational numbers, remember what I said, a rational number is a number that can be expressed in the form A over B, where A and B are members of what? Integers. A and B are members of integers, and then B should not be equal to 0. The reason why B shouldn't be equal to 0 is because when B is equal to 0, the solution of this fraction becomes undefined, because a over any number over what? Any number over 0 is what? Is undefined. So this is why I'm saying b should not be equal to 0 for this fraction to qualify to be what? A rational number. And then a and b are supposed to be what? Co-prime factors. So what are co-prime factors? So co-prime factors, when you look at a fraction, if you say a and b, or the numerator and the denominator are co-prime factors, it simply means that a and b, or the numerator and the denominator, are in their lowest term, meaning there's not supposed to be any number that can go, I don't know how I can say this, but in other words, the fraction cannot be divided by any number. It's in its lowest term. There shouldn't be any number that can go into this fraction. That's what we mean when we say a and b are co-prime factors. Okay, so let us look at what are known as repeating numbers. So we have these numbers on the screen, and sometimes they might ask you to say, show that this number here, show that this number is a rational number. How do you tell them that this can be expressed in the form a over b? How do you explain that to the marker? Let us look at that. Okay, so these are just examples. I think there are some exercises at the end which we are going to solve together. So these are repeating rational numbers. Then we also have terminating rational numbers, like the one that I showed you, which is 1 over 2. So 1 over 2 is a terminating rational number because it's not repeating. Then we also have repeating rational numbers, meaning they have numbers that keep on going this side. Let's look at this example, which says, in the following problems, find the form a over b of the given decimal expression. So in some papers or some books, they will not ask you like this. They'll just say, prove that 3.2 bar is a rational number. Sometimes they'll ask you to say, express this in the form a over b. It's still the same. So now, how do you work out such a question? So the first thing you say, let x be equal to the same number that you've been given. I'm going to start with that, 3.2 bar. So from there, the next step that you need to do is to move this point closer to the repeating number. But if you check here, if you check this point, or if you check this question, you discover that the point where it is, it's already closer to the repeating number. So the only thing that we need to do is to move the point covering the repeating number that we have this side. So the point here is going to move once, meaning for this point to move, it's not just moving. It means that we have to multiply this whole expression by what? By 10. So when we multiply the right side by 10, you are going to have 10x, and then when you multiply when you multiply the left side of x, you're going to get 10x. When you multiply the right side of x, you're going to have 32 point. Okay, let me just be following steps bit by bit so that you can understand, because I know there are some people that can't ask questions, but they are confused. All right, so we say let x be equal to 3.2 bar. So what you do here, we move this point to cover the repeating number. So in this case, we're moving it once, meaning we're multiplying the whole expression by what? By 10. Yeah, so this is what we have. So from there, what we do, if we multiply that and that, we're going to get what? 10x this side, and this other side, we're getting 32 point. This number is repeating, meaning we still have it this side. The other thing that we now need to do is to subtract. This expression from that expression. So how do we subtract? We now say 10x minus x is equal to, we're saying this minus that, then this minus that. So 10x minus x that side, and then this side we have 32.2 bar minus 3.2 bar. So 10 minus x, we're going to get 9x, and then this other side, when you subtract 32.2 bar minus 3.2 bar. So you see that these two bar and 2 bar will give us a what? A 0. And then we get 1 from 3 there. I'll put this side. So I have 12 minus 3, we're getting 12 minus 3, we're getting 29. Then there you remain with 2. 2 minus 0 there is 2. So you have 29 as the solution this side. So you have 29 this side. And then the value of x becomes 29. Since we're dividing everything by 9, divide everything by 9, the value of x becomes x over 9. So this is an expression in terms of a over b of what? 3.2 bar. We move on to the next question. So the next question is part B there, which is so we have okay.
The previous week, the question A, when we were multiplying with x, I don't know if you can bring those numbers back, or they are gone for good.
They are gone for good, but I can write what I wrote. So we had
okay. I just want that where we were multiplying 10 by the whole expression.
Okay.
I 10 open bracket x is equals to something like 3 point. Now, when multiplying, I discovered that it became 10x is equals to 32.2 bar.
Yeah.
Have we generated the other two? Because if we follow the how to multiply, we were just supposed to have 32 bar point 0.
That's a very good question. This is that's a good question. Do you know the reason why I said it's a good question? Every time I'm marking, if I give this exercise, almost everyone write what you're saying. And the reason why, and the other part which confuses a lot of people is this part which I was doing here. I'm sure some of you thought maybe he just doesn't know how to subtract numbers. I knew the final answer here, but I wanted to make you understand how to subtract decimals. This is where a lot of people find difficulties, multiplying and subtracting decimals. This is where a lot of people find difficulties. So follow me step by step. So here after multiplying, we have what? 3.2 bar. So if I multiply this by what? By 10. This 2 bar here, this is why we're calling these repeating numbers. This 2 bar means that the numbers are repeating, meaning we're going to say 10 times 3 point. There are a lot of 2's this side. It's still going. So this point, even if it moves here, it will still leave other 2's which are repeating this side. So this is the reason why after multiplying, I'll still have what? I'll still have 2 bar this side, because I'll still have a lot of 2's repeating this side. So meaning this 32 will still be 32 point what? 2 bar. I'm sure you understand why I still wrote this 2 bar here. Have you gotten the concept?
Oh, okay. It's now clear. I've seen.
Yeah.
All right, thank you.
And then the other part is on the part of addition and subtraction of decimals. A lot of people find challenges there. Let me also repeat that part. When you're subtracting here, you subtract this one. You say this minus what you have there. And it's not always that you're going to subtract what you have there with the first statement. It's just that here I didn't prepare any question that consists of, where I subtracted, where I was supposed to subtract this with maybe the other line which is somewhere there. Anyway, I'll send some practical examples in the group which I solved on YouTube, which has such questions. Which have such questions. All right, so Here we're subtracting this from that. So we have 10x minus x, saying this minus that and this minus that. And then we say this is equal to 32.2 bar minus what? 3.2 bar. So we subtract 10 minus x, 10x minus x. This will give us what? 9x. And then this other side we have 32.2 bar minus 3.2 bar. So this one is also a very simple and straightforward subtraction, because you just have to use the normal way of subtraction. And then we have 3 there. You make sure, so when you're subtracting decimals, you make sure that the decimal points are in the same line. This is the key when you're subtracting and adding decimals. Make sure that the decimals are in the same line, and then from there, these very simple things. I'm explaining this, and some people think maybe this is simple. These are some of the things that make a lot of people carry mathematics. Just these simple things: decimals, additions, fractions, simple things. You might find a person knows how to solve big questions, but because they don't know the small things, the foundations of mathematics, they end up getting wrong answers with a right procedure. Yeah, so when subtracting now, you say this 2 bar minus this 2 bar means that we're going to get a 0 now. Then we say point. We have 2 minus 3. We're going to get a 1 from 3 there, meaning we're going to remain with 2. And then I'll put this 1 there. So 12 minus 3, I'm going to get 9. Then here I'll have a 0. So 2 minus 0 is 2. So meaning I'm going to have 29 there. So I have 9x being equal to 29. So I'm going to divide by 9, divided by 9. Then the value of x becomes what? 29 over 9. So if you want, you can even prove that. If you have a calculator anywhere near, you can prove that, and you see it's going to give you 3.2 bar. Yeah, so this is the correct solution to that question. So I'll solve part B, and then the last part, which is part C, I'm leaving it as an exercise. You should solve it and submit it so that I check if you're understanding what I'm explaining. So the first one is, part B is, so again, we'll say let x be equal to what? 3.12 bar. So since we have two numbers here, we have two numbers this side. In the first one, we had one number, that's why we multiplied by 10. Here, we now have two numbers, so we're going to multiply by 100 on both sides. So we're going to have 100, then we have x is equal to 3.12 bar. So when we multiply by 100 there, we're going to have 100x this side, then being equal to, this side, the point will move 2 times, 1, 2. So I have 312.12 bar. This 1, 2 bar is repeating, so even after multiplying, it will still remain. After doing this, now we subtract this expression from that expression. So we say 100 minus x, we say 100x minus x is equal to 312.12 minus 3.12 bar. So 100 minus x, we're getting 99x being equal to, so again we go back 312.12 bar minus, we make sure that the point there, the decimal point, is in the same line with the one that is down. So 1, 2 bar minus 1, 2 bar, the answer is 0. Then we have a point there again in the same line. Then 2 minus 3, the answer is, it can't in this case. So we borrow 1 from 1. Just go back to grade 5. Don't just go back to grade 5 when it comes to this and binomial. even there's a part of binomial which requires you to find something like this, 0.001 to the power, maybe you have to the power 5. This, you have to visit grade 5 for you to solve this, grade 5, 6, somewhere there. Yeah, so this is where you find drama now. That's when you know that, okay, mathematics, yes, I know, I have understood, but I don't know the basics. Yeah, so these things, you just have to make sure that you know them. They're very simple, but confusing. Yeah, so we say we borrow on from 1 there, we put it there, 12 minus 3, we're getting 9 there. We remained with a 0 there. So 0 minus 0, we have 0 there. 3 minus 0, we have 3. And this is the answer there. So we put our 309 there. So we can divide by 99, divide by 99, so that we get the value of x as, here, make sure that you reduce it to its lowest term. There are some lecturers who will not give you full marks if you leave it like this. You make sure that you reduce it. I know that 3 can go into 3, 1, and then I know that 3 can go into 0, 0, 3 can go into 9, 3. Over 3 can go into 9, 3, 3 can go into 9, 3. So this is someone is saying, sir, 2 minus 3 is -1. It's not, it can't. Go back to grade 5. I'm telling you, go back to grade 5. You miss the point here. All right, yeah. So, yeah, so this is the solution. Okay. So when you're dealing with these things, they look very simple, but this is what makes a lot of people fail mathematics. They may look very simple like this. If anything, practice. All right, so yeah, because the most, again, the other problem is that you guys are not allowed to use calculators. That's where the problem comes in. Now imagine you're not allowed to use a calculator, and then you meet something like this under binomial. You need to simplify this, or they give you something like this, 2.01 raised to the power 5. Then they ask you to find the solution for this. It's a question under binomial. How do you do that? So it's not that, it's just that we're not doing binomial. I would have shown you, but you're supposed to split this. And then you raise it to the power 5. Then from there, you expand this using the binomial theorem. So it's a very simple question. Yeah, so see you in the next session. I believe this is the last page. Yeah. See you in the next session that we're going to have. Yeah, so let's continue attending the lessons. And then those that want to know more about the lessons, you can inbox me. And I've left one question here, which is C. Make sure that you solve it and submit through my WhatsApp line. Yeah, thank you very much. See you in the next session that we're going to have. Okay.
Before you go, the same track grade 1 was said. When you are multiplying decimal numbers,
yes,